An astrophysical plasma is a plasma whose physical properties are studied as part of astrophysics. Much of the baryonic matter of the universe is thought to consist of plasma, a state of matter in which atoms and molecules are so hot that they have ionized by breaking up into their constituent parts, negatively charged electrons and positively charged ions. Because the particles are charged, they are strongly influenced by electromagnetic forces, that is, by magnetic and electric fields. All astrophysical plasmas are likely influenced by magnetic fields. Observational evidence. Astrophysical plasma may be studied in a variety of ways since they emit electromagnetic radiation across a wide range of the electromagnetic spectrum. Because astrophysical plasmas are generally hot, often meaning that they are highly ionized, electrons in the plasmas are continually emitting X-rays through a process called Bremsstrahlung, when electrons nearly collide with atomic nuclei. This radiation may be detected with X-ray observatories, performed in the upper atmosphere or space, such as by the Chandra X-ray Observatory satellite. Astrophysical plasmas also emit radio waves and gamma rays. Space plasma characteristics. Space plasma, as first proposed by Hannes Alfvén and Carl Gunnar Thamer, divides into three main solar system categories: research and investigation. Both plasma physicists and astrophysicists are interested in active galactic nuclei, because they are the astrophysical plasmas most directly related to the plasmas studied in the laboratory, and those studied in fusion power experiments. They exhibit an array of complex magnetohydrodynamic behaviors, such as turbulence and instabilities. Although these phenomena may occur on scales as large as the galactic core, most physicists theorize that most phenomena on the largest scales do not involve plasma or effects. In physical cosmology, in the Big Bang cosmology, the entire universe was a plasma prior to recombination. Afterwards, much of the universe reionized after the first quasars formed and emitted radiation which reionized most of the universe, which largely remains in plasma form. It is assumed by many scientists that very little baryonic matter is neutral. In particular, the intergalactic medium, the interstellar medium, the interplanetary medium and solar winds are all mainly diffuse plasmas, and stars are made of dense plasma. The study of astrophysical plasmas is part of the mainstream of academic astrophysics and is taken in account for in the standard cosmological model. However, current models indicate that plasma processes may have minor role to play in forming the very largest structures, such as voids, galaxy clusters and superclusters. History. Norwegian explorer and physicist Christian Birkeland may have been the first to predict that space is filled with plasma. He wrote in 1913, "It seems to be a natural consequence of our points of view to assume that the whole of space is filled with electrons and flying electric ions of all kinds. We have assumed that each stellar system through its evolution throws off electric corpuscles into space. From this, he assumed that most of mass in the universe should be found in empty space." In 1937, plasma physicist Hannes Alfvén argued that if plasma pervaded the universe, then it could generate a galactic magnetic field. During the 1940s and 50s, Alfvén developed magnetohydrodynamics, which enables plasmas to be modeled as waves in a fluid, for which Alfvén won the 1970 Nobel Prize for Physics. Alfvén later proposed this as the possible basis of plasma cosmology, although this theory is now openly rejected as the expectant galactic and intergalactic magnetic field strengths have never been observed.